Hello juniors, today we're going to see electronic assignment 41, which is about logarithms. As you can recall from last class, we have seen logarithmic functions, but today we're going to focus only on the concept of logarithms, and we're going to see some properties that apply to logarithms, okay? So the objective for today's class is only one: interpret and apply properties and laws of exponents and logarithms. We have already seen the properties and laws of exponents, but now we need to complement that with properties and laws of logarithms. So we're gonna start investigating this by trying to solve these two problems first. In the first case, it says 2 to the power of x equals 8. If I want to solve, the idea is to find the value of x that satisfies the equation, right? So with the tools that we know up to now, we can solve this by equating the bases, right? Remember, I can, for example, convert, instead of writing 8, I know that is equal to a third power, right? So if I have the same base, I can equate the exponents, right? So I can say that x is equal to 3. And that's it. That is a result for this first part. But what will happen in this in cases like this? Let's see. First of all, I cannot convert 27 to any power of 5, right? If it was 25, then it would be 5 squared, but 27 is not 5 squared. So there's no way I can solve it through this method, okay? So in this particular problems is where the concept of logarithms becomes something interesting to use, okay? And I'm going to show you how to solve this, and we're going to later on see these properties, and you're going to practice with this on your own, okay? And you'll see that it's not something very difficult. So whenever we have this type of situation and we have the x variable in the exponent, and we want to solve for that x value, we want to leave the x alone, we need to apply logarithms, okay? If I apply logarithm on both sides of the equation, I will get logarithm of 5 to the power of x equals logarithm of 27, right? And whenever I have this situation, one property of logarithm, which we're going to see later on, is that whenever I have an exponent inside of the logarithm, I can bring the exponent down here and write it in front of the logarithm, okay? So that's exactly what I'm going to do. I'm going to rewrite this as x times logarithm of 5. Logarithm of 5 equals logarithm of 27. And we're almost done there, right? In order to solve for x, what I need to do is take this logarithm of 5, dividing down here, and then I will be able to find the value of x. So x would be equal to log of 27 divided by log of 5, okay? And then I can use calculator. I must use calculator for this, and we will get a value of x, which is equal to around 2.04. If you try this in your calculator, you'll see that you'll get that value. This means that if I go back to the original equation, this means that 5 to the power of 2.04 will approximately be equal to 27, okay? That's what we just found by finding this value of x, right? Okay, so that is why logarithms is sometimes very useful. So this is what we have seen from last class. Whenever we have exponents, we know that the 2, for example, here is a base. The 3 is called exponent or also logarithm. We're going to see in a second why. And this is a result, right? So this is shown in exponent form. But we can translate this. We can write this expression, which is the same as this expression over here, but using logarithmic notation. Whenever you see logarithmic notation, you have log, in this case base 2 of 8 equals 3. Okay, this 2 over here, which is down in the logarithm, is known as the base. The number 8 here is called an argument, and the result is called the logarithm. Okay, that's just for you to know. remember from last class we have defined the concept of logarithm, and now I think you will be able to understand this more clearly. It says a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. Okay, so you see, a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. In this particular situation, we see that in order to obtain 8, which is the argument, what should I do? 2 to the power of 3. Okay, so it's the quantity representing the power to which a fixed number must be raised in order to give a given number. Okay, so I think the concept is clear now that we can see this expression here. Okay, so here we have the same example. Log base 2 of 8 is equal to 3. How do we read this? The logarithm of 8 to the base 2 is 3. And how do we work with this? The rule is very simple. It's this number over here, which is the base, to the power of this number we have over here, which is the logarithm, and that should be equal to the argument, which is the number we have inside the logarithm. Okay? So basically what we're doing is 2 to the power of 3 equals 8. 2 to the power of 3 equals 8. Okay, so this is the most important thing you should remember. If b is equal to a to the power of x, then log of base a, log base a of b is equal to x, okay? Remember the rule is as follows. It's always a, or the base, the letter here, to the power of this should give me this, okay? So if I have this expression, this is the same as saying a to the power of x should equal b, which is what we have right here, okay? So remember that rule, because with that concept, you will be able to solve lots of problems. So it says, or, if b is a to the power of x, then x is the logarithm of b to base a. Okay, here are some examples to work with this. It says evaluate log base 5 of 125. When it says evaluate, it means I need to find the value of this, and without using calculator, right? Because if you plug in this in the calculator, you will get the result directly, right? But let's assume that we do not have calculator, okay? So in order to evaluate this, I need to first set this to x, okay? I'm gonna write equals x. So basically, if I'm setting this to x, what I need to do to find the value of x is follow the rule, right? 5 to the power of x should be equal to this value over here. Okay, so I'm gonna do a step-by-step process, okay? I'm gonna first of all write log base 5 of 125 is equal to x. So by following the rule, you should know that 5 to the power of x, 5 to the power of x must be equal to 125, right? Following this rule over here. So now I need to equate the bases, right? I know that 5 to the power of x stays like that, and 125, I know it's 5 cubed. 5 cubed. That means that the value of x is equal to 3. So the result is that, let me write it here, log 5 of 125, log base 5 of 125 is equal to 3. This would be the final result. Okay, then it says evaluate log base 64 of 4. So we're going to do the same thing. First of all, we're going to set this to 0. Log base 64 of 4 is equal to x. So 64 to the power of x should give me 4. So 64 to the power of x should give me 4, right? In order to be able to solve this, I need to have the same basis. I know that 64 is the same as saying 4 to the power of, to cube power, right? 4 cubed, yes. So 4 cubed, and this is being to the power of x again, should be equal to 4. So if you remember properties of exponents, I can multiply the exponents here, and we're getting 4 to the power of 3x, and this should be equal to 4 to the power of 1, right? So now that I have the same basis, I can equate the exponents. So we're going to say that this is equal to, so 3x is equal to 1. And that means, and I'm going to continue here, that means that x is equal to 1/3. So the logarithm of base 64 of 4 is equal to 1/3. Okay? I hope this is being clear for you. Okay, so that's the result. Let's move on to okay, so this was the first concept of logarithm, okay? This is the first property that you should always remember. Now let's go to a second. It says log base a of a is equal to 1. So when the base is equal to the argument, then the answer will always be 1. And let's see why. Let's solve this example. It says evaluate log base 4 of 4. If I do this, remember the rule. We're going to say first that log base 4 of 4 is equal to x. I want to evaluate that. So we're going to say that 4 to the power of x should be equal to 4. So 4 to the power of x should be equal to 4. This is to the power of 1, right? So we have the same base, so we can equate the exponents, and we're going to get that x is equal to 1. That means that log base 4 of 4 is equal to 1. So we prove that whenever the base is the same as the argument, the result is always going to be 1, okay? That's exactly what we're proving here. Let's move on to a third property. It says log base a of 1 is always equal to 0. So when the argument is 1, the result of the logarithm is always 0. Let's see why. Example, evaluate log base 5 of 1. We're going to do the same thing. This is log base 5 of 1 equal to x, right? So 5 to the power of x should be equal to 1. 5 to the power of x should be equal to 1. And we can always rewrite 1 as, let's see, 5 to the power of x equals 5 to the power of 0. Remember the rule that says any number to the power of 0 is equal to 1, right? So 5 to the power of 0 is 1. So now that I have, 5 to the power of 0 is equal to 1. So now that I have the same basis, I can equate the exponents, and we're going to get that x, right here, x is equal to 0, right? And that means that log base 5 of 1 is equal to 0. So we prove that whenever the argument is 1, then the result of the logarithm is 0, okay? Property number 4. Log base a of b is undefined for any base a if b is negative, okay? So what happens when the argument is negative? We should get an undefined answer. And let's see. Evaluate log base 3 of negative 27. So we're doing the same as always. Log base 3 of negative 27. Negative 27 is equal to x, right? So same rule. 3 to the power of x should give me negative 27. So 3 to the power of x equals negative 27. I know I can rewrite 27 as a 3 cubed. So 3 to the power of x equals negative, here I'm going to write 3 cubed. Okay? And, well, actually, it's better if I write this as, let me see, this is negative 3 cubed. That's better. Okay. But the problem is that there's no way that I can equate the bases, right? Because one is 3 and the other is negative 3. I'm going to write this as, I'm just going to leave it as minus, and here 3 cubed. You see that? I cannot equate the base. There's no way, because in one side I got positive 3, and the other side I got negative 3. So there's no way I can equate this. That means that the value of x, this means that the value of x is undefined. There's no value of x that would make this change its sign, right? There's no exponent that will make that change sign. So I cannot make this an equation. So I conclude that log base 3 of negative 27 is undefined. Is undefined. Okay, so let's move on now to property 5. It says log base a of 0 is also undefined. So when the argument is 0, the logarithm is undefined. If you try doing this, the one we just did in your calculator, if you put this log base 3 of negative 27, you should get math error. And same thing for this. If you put log base, for example, this one, log base 3 of 0, you should get a math error as well. Let's see why. If I want to evaluate, we're doing the same thing. Log base 3 of 0 is equal to x, right? So 3 to the power of x, 3 to the power of x should be equal to 0. So 3 to the power of x is equal to 0. Now, there's no way I can convert 0 to 3 to the power of something, because we know that 3 to the power of 0 is 1, it's not 0. So there's no way I can convert this to a 3 to the power of something. So since there is no value for that, we just conclude that x, again, is undefined. And that means that log base 3 of 0 is undefined. Here it says, logarithmic functions are only defined for positive numbers. So that's why we also get undefined, right? If you remember from logarithmic functions, we've seen that the domain is for x greater than 0. We do not include 0. That means that the value of 0 is excluded. And because it is excluded, it means that if we try to evaluate for 0, we're going to get an undefined answer, okay? Finally, property number 6, it says log base a of a to the power of n, okay, is equal to n. So this is a property that I applied at the very beginning when we solved the problem of 5 to the power of x equals 27. So let's see why this works. We're going to say that this is the same as saying, if I want to evaluate, this is log base 2 of 2 to the power of 5 equals x, right? So same rule. This 2 to the power of x should give me 2 to the power of 5, right? So 2 to the power of x should give me 2 to the power of 5. And since I already have the same base, here we have the answer, x is equal to 5. Okay, so basically, we prove that, I'm going to write here, that log base 2 of 2 to the power of 5 is equal to 5. Okay, so whenever the base of the logarithm is equal to the base of the argument in the logarithm, then the result will be directly the exponent. Okay, that's what we're proving with this property. I hope this is getting clear for you guys. Let's see, this is a summary of the properties of logarithms, all of what we have just seen. The first is a definition, right? If I have x equals a to the power of b, then I can rewrite this as log base a of x equals b. Remember, a to the power of b is equal to x, and that's exactly what we have written here. That's the first property. Then log of base a with argument a is equal to 1, log base a of 1 is equal to 0, log base a of b is undefined if b is negative, log base a of 0 is also undefined, and finally log base a of a to the power of n is equal to n. Finally, to finish with this assignment, we're going to solve some examples in order to see how we apply the concept of logarithm. So it says solve these equations. Remember, the word solve implies find the value of x, right? So log base x of 64 equals 2. How do we find the value of x here? Well, we're going to apply the concept of logarithm. We're going to say that x to the power of 2 must be equal to 64, right? So x squared should be equal to 64. And then I just solve this. How do I solve this? In this case, I need to apply square root. So x squared square root equals the square root of 64. And the square root of 64 is, remember, whenever we do square root, it's plus or minus 8. Okay? So those are the two possible values of x. Okay. Then we have log base x of 6 equals 1/2. Same thing here. We're going to do x to the power of 1/2 should be equal to 6, right? So x to the power of 1/2 should be equal to 6. If you remember from exponents, whenever we have x to the power of 1/2, this is the same as saying the square root of x, and this is equal to 6, right? So if I want to solve for x, I need to square both terms. I'm going to write this squared should be equal to 6 squared. So I can eliminate the square root. So this is x equals 6 squared, that's 36. And this would be the answer for x. Finally, for the third exercise, same thing, right? 2 to the power of negative 5 should be equal to x, okay? So I'm going to write 2 to the power of negative 5 is equal to x. And then I solve this. Remember, from the properties of exponents, 2 to the power of negative 5 is the same as saying 1 over 2 to the power of 5. I can take the exponent down and change its sign is equal to x, right? And 2 to the power of 5, that's 32. So 1 over 32 is the value of x. We could just leave it like that if we're not using calculator. So this is a result, 1 over 32. Okay, so these are just some examples of how we apply logarithms. We're going to see more exercises about this later on. I hope this was clear, and if not, please let me know. Thank you for your attention. See you, juniors.